We got time here. Okay, so everybody should open up to 3.3 in your packet, page 117. Compare and order decimals. We've been kind of touching on that, but we're doing a little bit more now. The table lists some of the mountains in the United States that are over 2 miles high. Anybody know how many feet are in a mile? Yeah, how many?
Like 5,800 something.
Close. 5,000. What do you think it is?
I think it's like 500.
Nope.
I know.
Yes, what?
5,280.
5,280 feet in a mile. 5,280 feet in 1 mile. Okay. So it says, how does the height of Cloud Peak in Wyoming, I'll underline that in red, compare to the height of Boundary Peak in Nevada? So where's Boundary Peak? This is Boundary Peak, and that's 2.488 miles high, and Cloud Peak in Wyoming, 2.495. And let's see here. It says there's a couple different ways you can do this. One way, it says line up the decimal point, start at the left, and compare the digits in each place value position until the digits are different. And so this is sort of what they're talking about here. So let's kind of ignore the problem they've asked for the moment. And let me line up two numbers here. I'll do 2.6714. And I'm going to compare that to 2.6638. And so when they tell us to compare digits, and you line it up according to the decimal, they're talking to us. They're talking about comparing the digits as they line up. So the 2's are the same, the 6's are the same, and now right here, though, we have a difference. This is a 7 and this is a 6. This is the ones place, this is the tenths place, this is the 100ths place. So in the 100ths place, suddenly we have a difference. Which one is larger? The 7 or the 6?
7.
The 7, right. So this right there immediately tells us that that number is larger. And I think this is probably the easiest way for you guys to compare decimals. Let me give you a couple more examples. And I'll just write down some numbers here. And you guys can tell me, you'll figure it out for yourselves here. So if I wrote 7.6921 and 7.6937, and then I wrote 8.621 and 8.599, and then I wrote 112.361 and 112.362. And I said to compare those. Well, the way I just showed you would be this. So let's take the first one here. I'm going to move it down here. I'm going to write 7.6921, and then I'm going to write 7.6937, and I'm going to compare those. All right. Well, the two 7s are the same. There's no difference. 6s are the same. There's no difference. 9s are the same. There's no difference. Right here we have a difference. In one we have a 2, and the other one we have a 3. Which is larger?
3.
The 3. So which number is bigger? The bottom number is bigger. Anybody have any questions about that?
Oh, this is easy.
Okay.
Easy.
All right. CM, come on back and work on this. And then you two work on this. I'm just paying attention. All right. Let's do another one here. I probably didn't even need to do all three, but let's do one more here. Let's do 8.621 and 8.599. Let's compare those. So let me pull a here, Mr. Duhamel. So we look at the 8s, they're the same. What about here?
The 6 is already bigger.
So which number is larger?
The top.
The top number is larger, okay. But wait a second, right here we have a 9 and a 9. And they're so much bigger than the 2 and the 1.
Yeah.
What do you think?
The top one's still bigger
The-
because the 6/10 is bigger than 900 to 9,000.
That's right, that's right. Even if these were zeros,
Yeah, it's
this would still be larger.
Wait, why? Because the
it's
two.
bigger.
Because the 6 is bigger than the 5.
Oh.
This is the 10th place. This is the 100th place. And this last one is in the 1,000th place. So when you can line up the decimals and you compare them, whichever number is larger, that's it. All right? So that's what they're talking about here. And I think they kind of go the long way around the barn explaining that. I think actually my example works a little bit better. But so let's just walk through this here really quick. It says since 9 is, they compared these now. So compare the 1s, the 2s are the same, the 4s are the same. Now right here, this is what they're talking about, the 9 and the 8. Since 9 is greater than 8, then 2.495 is greater than 2.488. And 2.488 is less than 2.495. So Cloud Peak, again, this is what we're talking about here, these two peaks, and this is in miles. So Cloud Peak is greater than the height of Boundary Peak. Now it says compare another way. It says compare the height of Cloud Peak to Wheeler Peak. All right, so let's go over here. So we're still working with Cloud Peak. That's what I had marked in red. Wheeler Peak, I'll circle that one in green. And so let's line them up here. The 1s are the same. The 10ths are the same. The 100ths are the same. And now right here we notice a difference. This one here is 5 thousandths and this is 3 thousandths. 2 is equal to 2, 4 is equal to 4. We're comparing them. 9 is equal to 9. 5 is greater than 3. Since 5 is greater than 3, then 2.495 is greater than 2.493. And 2.493 is less than 2.495. So the height of Cloud Peak is greater, again, greater than. All right. Questions on this? This is really pretty easy to compare decimals, I think.
Yeah.
If you just line them up like that. How many knew that? Well,
Oh, wait.
how many didn't know this, and this is a new way to figure out which one's larger so about half the class. That's good. Okay. You did this last year this way? Okay, cool. Cool. Okay. They have a question here. It says, explain why it is important to line up decimal points when comparing decimals. Well, anybody have an answer for that? Mr. Duhamel, what do you think?
Because if you get them mixed up, you can have the wrong answer.
Yeah, that's a fine answer. If you get it mixed up, if you don't line up the decimals, you'll get a wrong answer. Okay, good. All right, turn the page. All right, in this one it says Mount Whitney in California is 2.745 miles high. Mount Rainier in Washington is 2.729 miles high. And Mount Harvard in Colorado is 2.731 miles high. It says order the heights of these mountains from least, okay, this is important, from least. So you're starting with the smallest one to the greatest one. Which mountain has the least height, or which mountain is the shortest or the smallest? and which mountain has the greatest height. So step 1, it says line up the decimals. There are the same number of ones, so same number of decimals in each one. Circle the tenths and compare. Well, let's look at the tenths here. Let me pull a stick here. Miss Lehman, what are the tenths? Yeah, the sevens. So let's just circle the sevens. All right. So there are the same number of tenths. Then step 2, it says underline the hundredths and compare. So Mr. Paulson, which ones are the hundredths?
The two, or the two,
The 2's here?
no. The 4, 2, and 3.
Yeah, very good. 4, 2, and 3. And so that's because the 2's are the same, the 7's are the same. This is in the hundredths place. This is the first time we see that there is actually a difference. And so you guys have learned, or some of you relearned or remembered, that you just look and see which one has the largest digit. Which one has the largest digit? Whitney, okay. So it says since 2 is less than 3 and 3 is less than 4, the heights in order from least to greatest are, it'd be 2.729, because that's the smallest one, because that's the smallest digit, 2. Okay. The next largest would be the 3, and that would be Mount Harvard, and that'd be 2.731. And the last one, which is the tallest, it's going to be Mount Whitney, 2.74, because 4 is the largest, 2.745. So then it says, so blank has the least height. Well, I don't know if they want the name or the number, so I'll put 1.4. Oh, wait a second. Scratch that out. The least height would be 2.7. 2.729, I guess. 2.729.
Can you put the name?
You can put the name if you want. And the greatest would be 2.745. Okay. They weren't specific as to which it should be. Yeah, Mr. Villegas?
My mom's last name is Whitney.
Oh, cool. All right. Let's see here. Well, we got to go to that assembly here in about 10 minutes. I'm going to let you guys do this. And the next page, page 119 on your own. Quietly work on that, and I'm going to call you guys up to check your homework.